In the next few screencasts, we are going to look at concentration units. And all concentration units define the amount of solute in a particular amount of solvent or solution. Now, quantitative units are either going to be based on the mass of the solute or the moles of the solute per amount of solute in solution. And so we are going to see, sometimes it can be amount of solute, sometimes it can be divided by amount of solvent, or more often we're going to see amount of solute divided by amount of solution. We will see the sum, but for the next two screencasts, this is what we're going to focus on. These are just quantitative concentration units based on mass to volume ratios. An example of this would be if you've had a blood draw, right? So the concentration of molecules in blood are generally given in units of milligrams of the substance per deciliter, like cholesterol is given that way. So this would be something that you would run into when you see any of your lab work from medical visits. So the two that we're going to look at in this screencast are mass per volume, which is given as a percent, or mass per mass, which sometimes is shown as percent M over M, or sometimes it's also known as weight percent in some older text. And so when we look at this, the percent of mass over volume equals the grams of the solute divided by the milliliters of solution times 100%. And then the mass, the percent mass over mass, or weight percent, is given as the grams of the solute over the grams of the solution times 100%. And so let's do an example of using these in calculation. So we're going to calculate the mass per volume percent composition, or percent M divided by V, of a 0.3 liter solution containing 15 grams of glucose. So it's asking you to calculate the mass per volume percent. And so what I like to do with these problems is I like to copy down the formula first, because it gives me a clue of what I need to fill in. And so that's the grams of the solute divided by the milliliters of solution multiplied by 100%. And so when we look at this, we see here that we have a mass, and that is 15 grams. And when I look at that, that equals the grams of the solute. And then I see my volume, right? And that equals 0.300 liters. But this is where I stop, because we've got liters here and milliliters here. So my very first step before I plug any numbers in is I need to convert to the proper units. And so grams are already in the proper unit. I don't need to worry about them, but I need to come here and say, look, we've got 0.300 liters, right? And in 1 liter, I know there's 1,000 milliliters. And so that gives me 3.00 times 10 to the second milliliters. So I want to remind you, in your homework, if you put this in as 300, it will not mark it as the correct amount of significant figures. So your best bet is to do scientific notation. So now we have it in the correct units. And so the next thing we just need to do is plug in to the formula. And so to do this, what we're going to do is we're going to say, great, we have 15 grams. We are going to divide this by 3.00 times 10 to the second milliliters and multiply that by 100. And that's what gives us our percent. Okay, so when we do that, we should get 5.00%, and we do M over V here, and that tells us if this, you have to add the M over V or the M over M, because that helps us distinguish between the two. So make sure you add that in when you report your answer. Now, There are other mass to mass concentration units. We run into these with a lot of times toxins. And so this is parts per thousand and parts per million. And that's the gram of the solute over the gram of the solution. And if it's parts per thousand, you just multiply by that by 1,000, right? And that gives you the ppt. That's how we represent it. And your book is going to say 10 to the third, but that's what you're doing. And then you're going to take for parts per million, you're going to take the grams of the solute and divide by grams of the solution and just multiply by 1 million, which is 10 to the sixth, and that will give you parts per million. And then sometimes you'll see parts per billion, and you just take the grams of the solute over the grams of the entire solution and multiply that by 10 to the ninth, and that'll give you parts per billion. And again, these are most often used to give us very small amounts of concentrations of mass. And a lot of times these are given to us, toxin amounts are given to us, or environmental contaminants.